At this point, you know how a VGA interface actually works, and you know how to develop a hardware-based VGA controller to drive a VGA monitor. However, if you want to develop really interesting applications using hardware alone, the task will be really tedious. So in this module, we will move into building a whole video subsystem that can be plugged into the SoC that we've been developing so far. And in this way, we'll have a processor to help us develop really interesting applications or even games. So in this module, I'll be actually building that video subsystem, and that video subsystem should be able to generate new pixel data, maybe process pixel data, and even display that pixel data, or basically drive a VGA monitor. So it'll have all these components. Specifically, I'll be talking about what we call video IP cores, which are these boxes you see in here. The video IP cores are similar to I/O cores that we've seen before. However, they're not independent of each other. So in the video subsystem, a video IP core is not independent from the other video IP cores. Specifically, they're connected in a chain, basically, in a cascading chain. So you have a video IP core in here, connected to another one, connected to another one. You can think about it as in series. And a pixel goes to one, it gets the output from one, goes to the second one, and the second one, and so forth. So what we have is we have a stream of pixel data that are moving all the way to the synchronization circuit. So we'll be developing that system, and that system is an example of what we call a stream processing system, because it actually takes pixel data streams and actually goes and maybe generate data, add data to it, or add pixel data. Some video cores will add video data, some video cores will just process them, and so forth. So more generally, we'll see that because I'm thinking that the pixel data is actually moving from left to right, the first few IP cores are the ones that will be generating data, and then the ones in the middle will be the ones that actually modify the data a little bit. For example, we will have something we call a frame buffer, and the frame buffer is basically just a blank canvas that the processor can actually go in and just fill it with different data and tell it which pixels should have what data point. Basically, it's just a blank, sheet that the processor can actually write into, and you can display it on the monitor. We'll also develop the test pattern, the bar test pattern, basically generator, and so forth. And as video IP cores that actually modify data, we will be talking about how we convert from color to grayscale. We'll also do some IP cores, or we're going to develop some IP cores that actually add some video data. So for example, a mouse pointer on top of something, or maybe a game character like a ghost or something like that on top of that. Eventually, the very last module, or the very last IP core, is actually the synchronization one. At this point, you should be able to build it. It's the same exact one as the basic one. However, we're going to be building one that is a little bit more robust and has something we call a line buffer. And the reason why is because the VGA actually operates at a certain frequency, because the monitor expects certain pixel clock rate. However, the rest of the system operates at the same exact frequency that the whole system is working, which in our case probably is 100 megahertz. So I have a couple of frequencies. So what we have two clock domains, one for the VGA and one for the whole system in here. And that particular buffer in here will help us actually do some clock domain crossing. That will help us. So we'll be talking about how we build that, how we make it a little bit more robust.